So today we're going to take a look at 8.2, trigonometric ratios. And clearly our math humor has been horrible since we've been doing it by ourselves. So we've kind of paired up again, and we're going to try this together.
Yes.
So, math humor, let's take a look at the question. The question is, what happened to the geometry student who went to the beach to catch some rays?
Well, he became a tangent. Tangent, gentlemen, get it, you guys?
Oh my gosh. So our lesson is focused on trigonometric ratios, and trigonometry, where does that word come from? Well, it actually comes from two Greek terms, and those two terms are trigon, or trigon, and that means triangle, and metron, which means measurement. So we're talking about triangle measurements when we're dealing with trigonometry. This leads us then to trigonometric ratios, and when we're dealing with trigonometric ratios, I don't know if you've noticed, but on your calculators, there are three words, sine, cosine, and tangent, and those are our three trigonometric ratios, and we're dealing with those trig ratios in any right triangle. It has to be a right triangle in order for us to use these trigonometric ratios. Now, the ratios are essentially ways in which we can compare legs to the hypotenuse, or legs to each other in our right triangles. Now, if I were to take a look, let's work with angle A here on my triangle. Here's angle A. And when I work with angle A, if I am going to talk about the ratio between, let's say, the leg opposite of angle A and the hypotenuse, if I take the leg opposite of the angle, which was A, and the hypotenuse, and I compare those two, that is actually our trigonometric ratio for sine of the angle A. So sine uses our leg opposite of the angle and the hypotenuse, and we're comparing them. Cosine, if I talk about the trig ratio, cosine actually works with the leg that is adjacent to our angle. So here's angle A, and the adjacent leg is the leg that helps to make up the angle. So B is my leg adjacent, and then C is my hypotenuse. So for cosine, I would take the leg adjacent, which is B, and divide it by my hypotenuse. That's how I get the cosine for angle A. The last trigonometric ratio is tangent, and tangent deals with both of the legs, but first we would deal with the leg opposite of my angle A, so the leg A, and then it's compared to the leg adjacent to my angle A, which is B. So tangent is always taking your opposite leg over your adjacent leg, so it would be A over B. Now, what you have to realize, though, is the trig ratios are always utilizing the acute angles in our right triangle, and never am I using a trig ratio with the right angle. Now, you probably noticed this on the bottom here, and it says SOHCAHTOA. I don't know how many of you have ever heard of SOHCAHTOA, but it's a neat little way to remember how in the world are we supposed to figure out what sine, cosine, and tangent are, and which sides of the triangles are we utilizing with each of those ratios. So if I take a look at sine, so sine, we're going to put a S-I-N down below that. Sine uses the leg opposite of our angle over the hypotenuse. So that's why we say for sine it is opposite over hypotenuse. That's our so. For cosine, cosine uses the leg adjacent over my hypotenuse. So for cosine, I'm using the adjacent leg divided by my hypotenuse. And the last one, for tangent, we are using the leg opposite over the adjacent leg. So for tangent, you're using opposite divided by adjacent. This is just a nice little way for us to remember which legs to use, or which sides of the triangle to use, with each of our trig functions. So let me go ahead and run through the example here with you. And what we want to do is we want to find each of the ratios as a fraction and decimal to the nearest hundredth for each of these. So if I'm talking about sine of angle S, that means we're going to take a look at angle S here. Here's angle S. And if I'm talking about sine, remember with sine, if I write it down, it is SOHCAHTOA. All right. So SOHCAHTOA. If I'm dealing with sine, I need to use the opposite leg over the hypotenuse. So the leg opposite of angle S is 3, and the hypotenuse of my right triangle is 5. So the ratio I would write for sine is 3 divided by 5. And you can say that that to the nearest hundredth is the same thing as 0.6. I know I don't have to do necessarily 0.60. You can if you like. Cosine of angle S then. Cosine, ka, adjacent leg over hypotenuse. Now a lot of kids get tripped up because they're like, adjacent, which one is it, 4 or 5? Well, here's the thing. It's an adjacent leg, and I only have 2 legs. So the adjacent leg is 4 over the hypotenuse, which is 5. So I would have 4/5, otherwise known as 0.80, because that's to the nearest hundredth. The last one here for angle S is tan, and tan uses the opposite leg over the adjacent leg. So the opposite leg for the angle S is 3, and the adjacent leg to angle S is 4. So I would say, oh, we are dealing with 3 over 4, otherwise known as 0.75. So what I would like for you to do is go ahead and switch up your angle to the angle E and do sine, cosine, and tangent on your own. Come back and we'll take a look and see what our answers are. Okay, so let's go ahead and take a look. On sine of angle E, sine opposite over hypotenuse. So the opposite leg to E was 4. The hypotenuse was 5, so it's 4/5 or 0.80. Cosine of angle E, cosine ka, adjacent over hypotenuse. So the adjacent leg was 3. The hypotenuse was 5, so 3 over 5, which gives me 0.60. The last one, tan of angle E. Tan, opposite over adjacent. Opposite leg was 4, adjacent leg was 3, so it's 4/3, otherwise known as 1.33. Now in this example, what we would like to do is we would like to come up with the cosine of 30 as a fraction. So I'm going to write down cosine of 30 degrees equals, and we're going to come up with the ratio. Now, if I'm looking at 30 degrees is right here. So I'm taking a look at this angle, and I would like to do the cosine. Now, remember, cosine is ka, which means you're doing the adjacent leg over the hypotenuse. So the leg adjacent to angle 30 degrees is the one that helps to make it up, which is s over the square root of 3. So I'm going to say adjacent is s over the square root of 3. Divided by, then, the hypotenuse of my triangle, and the hypotenuse is always opposite of my right angle, and the hypotenuse was 2s. Now, to simplify that down, I know that the cosine of 30 degrees, then, is going to be where I could take this s and this s, simplify it down, and get the square root of 3 over 2. And you're all done, because you wrote it as a fraction. We want to make sure that you do know how to use your calculator, though, also when finding out these values. So if you've got a calculator with you, make sure you pull it out. Pause the video if you need to go get one. But here's the thing. On your calculator, hopefully you can find there are 3 buttons, sine, cosine, and tangent. They should be somewhere in the middle of your number keypad, above the numbers, actually. And what we're going to do here is we're just going to go ahead and type in the 2 examples we have and make sure that when you type them in, you're getting the same decimals. If you're not, please make sure that you ask your teacher to clarify why it is that you might not be getting the same answers when you go through this video, because it's very important that you know how to do this on your calculator. And it's hard for us to show you right now, so I'm just going to talk you through it. So for the first one, sine of 43 degrees. I'm going to look for where the sine key is in my calculator, and when I hit the sine key, it's going to open up sine with an open parentheses. All you have to do then is put 43 next to it, close your parentheses, and hit the equal sign. And when you do that, hopefully you end up getting a decimal of 0.68 to the nearest hundredth. Same thing happens for cosine. When I hit the cosine key on my calculator, it opens up a set of parentheses. I put 84 down, close it, and then your calculator should spit out something like a 0.10. It'll be 45284, but since it says round to the nearest hundredth, that would be 0.10. If you have questions on this, make sure, or you're not getting these answers, make sure you ask your teacher for clarification in class. So we're going to try this example out, and I've got triangle ABC, and it is our job to find out the measurement for BC. And actually, I'm going to put an X down for BC. Once we find it, we're going to round our answer to the nearest hundredth. So I noticed there are a couple things that they're giving me. They are giving me the angle at B. They're telling me the side opposite of angle B, and I want to find the side adjacent to angle B. So anytime I'm given an angle, what I like to do is I like to categorize the sides that I have. So I usually do this. I'll usually say, oh, I'm working with this angle, so that means that this side is the one opposite of my angle, so I'll put an O down. And this side right here, it's not a hypotenuse because it's not across from the right angle. It's actually the adjacent leg. So I like to put a little A down there. That way I notice I'm using O and A. And if you remember, we talked about so, ka, toa. If you think about the letters, since you have an O and an A, it's not going to be sine, it's not going to be cosine, but it's definitely going to be tangent. So we're going to be using the tangent function here in this case. So I'm going to say tangent. Tan of what? Well, here's the thing. Tan of, you always want to put the angle that you're using next to your trig function. So it's going to be tan of the angle, which was 15, equals, then it's opposite over adjacent. So opposite, which is 10.2, over the adjacent, which is x. So 10.2 over x. All you have to do then is just solve for the x. Now normally when I've got an x on the bottom here, what I like to do is I will either put tan of 15 over 1 and cross multiply, or I like to just multiply both sides by x. So when I multiply by x, I get x tan of 15 equals 10.2, because these x's will cancel. And then I like to divide both sides by tan of 15. So when I divide by tan of 15, I make sure that in my calculator I type in the 10.2, and then I do divided by, and then I hit my tan key, and when it opens parentheses, I put 15 in, close my parentheses, and hit enter. When I do that, I get 38.0, and then here's the thing, it said round to the nearest hundredth. Mine says 0.66, so we're going to do 0.7, and that was in feet. In this example, what I'd like for you to do is I would like for you to go through this and draw a diagram. You're going to draw out what a 16-foot ladder looks like propped up against a building. It's going to form an angle with the ground that measures 55 degrees, and I want you to go ahead and I want you to find how far up the side of the building the ladder actually reaches. So I want you to draw your diagram out, I want you to label it, I want you to set up your trig ratio and solve it. Once you're done with that, make sure you start the video up again, because you're going to pause it now while you do it. I'm going to write the answer down, start the video up, and we'll check and see if we're on the same page. All right, so let's take a look at this. I have my drawing diagram here. I have a 16-foot ladder, so that's going to be my hypotenuse. The angle of the ladder made with the ground was 55 degrees, so I've labeled that. And I want to find out how far up the building it is, so I labeled that as an x. So when I'm looking at this, here's the angle I have. I do know that the side opposite of that angle is what I'm looking for, so I'm going to put an O there. I also know the 16-foot ladder, that's actually my hypotenuse. So I've got an O and an H, and when I have O and H, that's so. For sine. So I'm writing it out, and I'm going to say, okay, we're going to do the sine of 55 degrees, because you want to put your trig function and then the angle right next to it. So sine of 55 degrees is equal to the opposite, which is x, over the hypotenuse, which is 16. So sine of 55 equals opposite over hypotenuse, x over 16. Now, if I've got to solve for my x, I'm going to multiply both sides by 16 to get it off of the bottom. And that leaves me then with 16 sine of 55. That's what x is, 16 sine of 55. So what I'd like for you to do is I'd like for you to actually take that and plug it in your calculator as you see it. So 16 times sine of 55. You are not taking 55 and multiplying it by 16, because the sine owns this degree measurement. So do not multiply those two numbers and then take the sine of it. You are just taking 16 and then multiplying it by the sine of 55. When you do that, I ended up getting 13.1 feet. It didn't say how much to round to, so I rounded to the nearest tenth. All right, new example. What I would like for you to do, and I know it does not say it in the directions, can you guys do me a favor? I want you to do it on your own, and I want you to solve for the length of FD then, okay? So pause the video, solve it on your own, and when you're ready, start it up again, and hopefully we'll have the same answers. Let's take a look at the work. So I've got angle 39 degrees, and if I start labeling them, this is my adjacent leg. And then the one I was looking for, FD, is actually my hypotenuse because it's across from my right angle. So I've got adjacent and hypotenuse. So it doesn't mean sine, it doesn't mean tangent, it actually means cosine for ka. So cosine says you're going to take the adjacent over the hypotenuse. So cosine of the angle, it's always cosine, sine, or tangent of the angle, and my angle is 39. So cosine of my angle is equal to the adjacent leg over my hypotenuse. So it's 20 over x. Again, going through and solving, I'm going to multiply both sides by x to get it off the bottom, which leaves me then with x cosine of 39 equals 20, which is what I have here. Then, to get the x by itself, since it's a multiplication, I divided both sides by cosine of 39. Then I took the 20 divided by cosine of 39, plugged in my calculator, and I got 25.74 meters. So we've got two more examples here. Why don't you go ahead, keep practicing. You're going to find x in both of these examples on your own. Pause the video at this point when you're set and ready to check the answers. Start it up again, and I'll have the answers written for you. All right, here we go. So taking a look at the first one. I've got the angle. Always start off with the angle. So I have my angle 63 degrees. I notice I've got the opposite leg and the hypotenuse. So opposite hypotenuse is sine. Sine of the angle is equal to x, that's opposite, divided by my hypotenuse, which is 12.9. I want to get the x by itself, so I'm going to multiply both sides by my denominator, 12.9. When I do that, those are gone, and I'm left with x equaling 12.9 times the sine of 63. Plug in my calculator, I get 11.49. Next one, starting off with the angle of 70 degrees, I notice I've got the adjacent leg and I have the hypotenuse. So cosine, because it's adjacent hypotenuse, cosine of my angle 70 is equal to 2.6 adjacent divided by my hypotenuse of x. Got to multiply both sides by the denominator of x. That gets rid of the x's over here, but that leaves me then with x cosine of 70 equaling 2.6. To get x by itself, I'm going to go ahead and divide both sides by cosine of 70. Plug 2.6 divided by the cosine of 70 into my calculator, and I end up getting 7.60. In this example, I have a kite, and we're flying it at the end of a stretched 150-foot string. So I've got a kite. I'm going to draw my kite out. Whoop! That works. And it's at the end of a 150-foot stretched string. And there you are, right? So then, it says that the string makes an angle 62 degrees with the ground. Oh man, it's getting good. I want to find the height of the kite. So this actually makes a right triangle, and I want to find the height. So now that I've set it up for you, why don't you go ahead, solve it using your trig ratios, and then double check with me, see what the answer is. Of course, pause the video though, and then start it up when you're ready. All right, in this problem, hopefully you saw how to use the sine ratio, because I've got my angle 62, I have the opposite side, and I have the hypotenuse. So that means opposite over hypotenuse would be sine of x divided by 150. So sine of the angle 62 equals x divided by 150. I'm going to multiply both sides by 150 to get rid of it. So that means that x would equal 150 times the sine of 62. Throw it in my calculator. I get 132.4 feet. It did not tell me where to round to, so I just went with the 10th. So in our last example here, we have the Pilatusbahn in Switzerland, and it's the world's steepest cog railway. The steepest section is actually section AC, and it makes an angle of about 25.6 degrees with the horizontal, and it rises about 0.9 kilometers. What our job is to figure out how long is this section of the railroad track. So I'm going to put an X there, and we're going to figure that out. Well, actually, you're going to figure it out using your trig ratios. Last example, you're going to pause it, work out on your own, and then when you're set and ready, come back to me. I'll have the answer for you. All right, taking a look at this one, I've got the angle of 25.6 degrees. I have the opposite leg labeled, and I'm trying to find the hypotenuse. So opposite hypotenuse. So sine. It's going to be sine of my angle, 25.6, is equal to my opposite, 0.9, over my hypotenuse, x. X is on the bottom, so we're going to go ahead and cancel it out by multiplying both sides by my x. So I have x times the sine of 25.6 is equal to 0.9. To get the x by itself, you're going to divide by sine of 25.6. So in my calculator, I'm going to throw that in there, and it said round to the nearest hundredth. So we know that this railway track is actually going to be 2.08 kilometers. I know it was a lot today, but if you have any questions, please make sure you write them down and you ask in class. It's very, very important that you do so. Until next time, have a great night, and we'll talk to you later.